All right, class example number 1 on our review. According to the 2010 U.S. Census, 11.7% of people in the state of Oregon were Hispanic or Latino. A political party wants to know how much the impact of Hispanic and Latino vote will have, so they wonder if that percentage has changed. They want to see if there's a different percentage now, right? So this is our set assumption at the beginning that it's 11.7%. So as you can see down here, I got my HO is that the P is 0.117. And notice it's a percentage, so I'm pretty sure this is going to be a proportion test, a one sample z-test for a proportion, because they give us one sample here. A random sample of 853 adults, 113 were Hispanic, and that's a percentage, 113 out of 853, and that's your p-hat. It's the one you calculate from the sample. So I'm going to calculate that now. 113 out of 853 is 0.1325. And I can go ahead and get Q-hat as well, because I know it's just 1 minus that. Or you can do 853 minus 113, and it's 740, because I'm going to need that number later. So go ahead and do that anyway. Get the total number in. N is 853. And subtract the 113, and you get 740. And that is 0.8675 for Q-hat. Those are P-hat and Q-hat. So can the political party conclude that the Hispanic proportion of the population has changed since 2010 using a significance level of 0.05? So I set all my variables first, and we got our P-hat and Q-hat. P-naught is 0.117. Q-naught would be 1 minus 0.117, which is 0.883. And N is 853, and N's an important number here too. My HO, my assumption at the beginning here, is that P is equal to 0.117. So they'll give you like the assumption up here at the beginning is 0.117. And my HA, the alternative hypothesis, what I'm trying to find evidence for is that P is not 0.117. It just says changed. If it would have said increased or decreased or improved or any sort of language that would suggest going up or down, it would be greater than or less than, but this just says changed or is different or something like that. That would be not equal to. So it's not equal to in this particular situation. So what I'm going to do next is I'm going to put this into Staplet. And in Staplet, let's go ahead and pull up Staplet right here. You're going to pause the video if you need to get to Staplet right now, and I'm going to go down to a one sample z-test. See, this is a z-test for a proportion one sample, and I'm going to click that. And I've already put it in, so if you need time, pause the video and get these in. You want Hispanic at 113 and non-Hispanic at 740, like we had listed right here, 113 and 740. And this is how you want to put it in. Put it in Hispanic first and non-Hispanic at 740. All right, so I'm going to begin analysis. And I get my P-hat and Q-hat, the 0.1325, 113 out of 853, and then 740 out of 853. And this is where I can run my test, my one sample z-test. And the success should be set to the right one as long as you put it first. And we don't want to do greater than or less than. We just wanted not equal to. And remember, we wanted it not equal to the set assumption at the beginning, the 0.117. So not equal to 0.117. So I perform inference, and there is my p-value and my z-value. So I'm going to write those down, those p-values and z-values. So my p-value, give me just a sec. The p-value is 0.1597, and my z-value is 1.406. Oops, 1.406. So I've got my p-value and I've got my z-value. So my conclusion I would come to here is, since the p-value of 0.1597 is less than 0.05, which is a significance level. We do not have convincing evidence the proportion of Hispanics has changed, so we fail to reject the HO. So the p-value failed to reject the HO, so we still want to find the confidence interval as well, because you want some practice finding confidence interval. So the next thing I'm going to do is find a 95% confidence interval, because this is two-tailed, as it is a not equal to. So it's going to be, the confidence interval is going to be 1 minus alpha. So it's 1 minus 0.05. And so it is 95% confidence interval. So it's a 95% confidence interval this time. If it would have been one-tailed, it would have been a 90%, because you double the alpha. Remember, for one-tailed, if it would have been one-tailed, greater than or less than, confidence interval would be 1 minus 2 alpha, which is 90%. But it's not in that in this situation. This is the correct situation for this problem. It's a two-tailed. So I'm going to do a 95% confidence interval. And I'm going to show you by hand how to find SE and ME now, because that can happen on the test where they ask you to find SE and ME. And SE is just a formula you have up here. It's the square root of p hat times q hat over n, all inside of a square root. So let's do that. That is the square root of, and p hat is 0.1325, and q hat is 0.8675 over n, which is 853. So if I want the standard error, that would be my calculation for it. So let me pull up my calculator here, Desmos Scientific, and throw those numbers in there and see what I get. So to do this in Desmos Scientific Calculator, I find the easiest way to find an SE is to hit this square root button right here, and then this fraction, the a over b, so it makes a fraction for you in there. And then I do 0.1325 times 0.8675 over 853. And I get 0.0116. I'm going to take this to 4 digits. 0.0116. 0.0116. All right. And then to be able to find ME, ME is going to be Z star times SE, which is listed up here. You see, ME is Z star times SE. So I need Z star. And you'll have a formula sheet. By virtual, she might have it up on the board, but we'll have a formula sheet with this on it in class. And you look it up for 95%, and it's 1.96. So it's 1.96. 1.96 times... And watch what I'm going to do in the calculator now. So in the calculator, I'm going to go down and I'm going to do 1.96 times, and I'm going to grab this whole thing right here and copy it and paste it, because that's going to be more accurate than just using the 4 digits, because you might be like a little bit off if you round instead of just bringing down the whole thing. So I did that, 1.96 times that, and I get 0.0228 if I were to go to 4 digits. Well, I'll put right here 0.0116, but in the calculator I brought more digits than that. So I get 0.0228 0.028 as my ME and 0.0116 as my SE. And then my confidence interval at 95%. If I wanted to do it by hand, it would be P hat plus or minus the ME. You might want to write that formula down, though you're not really going to need it with Staplet. So it would be 0.1325 plus or minus 0.0228. And it would split off into lower bound and upper bound, but you're just going to use Staplet. And so go back to your original calculations in Staplet. And right here where the drop-down menu is for z-test, you can go to z-interval and do a 95% interval. And there is my interval right there, 0.1097 to 0.1552. So let me write that in. So my interval is 0.1097 to 0.1552. So that means I am 90% certain the true value is between those two numbers. So therefore, my final conclusion here is that we are 95% confident the true proportion of Hispanics is between 0.1097 and 0.1552. And since 11.7% is between those two percentages included in this interval, we do not have convincing evidence and we fail to reject HO. So that is our one sample proportion for a z-test, and that is the first example of this review.